Okay, I'm going to give you a chance to try one of these now. So I got the ramp facing in the other direction, and we'll say that the weight is 250 pounds, and the ramp is at a 34-degree incline. And so we want to know how much weight does this guy have to, well, resolve this into the horizontal vertical components, and then how much weight does this guy have to support. So you can go ahead and press pause, give it a try, and then you can start it back up again and see how you did. Okay, so let's give this a try here. We're gonna bring this vector down, and we'll say that's 250, and that's the weight going straight down. And then you have one that's you have a component that's perpendicular to the ramp coming down here, so that this is this would be the one of the components that's perpendicular to the ramp, and then another one that's horizontal to the ramp, like this. Okay, and so these basically would be like your parallelogram, where this is the resultant. And then what you get here is that these two are perpendicular to the ramp, so this is 34 degrees like that, and then this angle is going to be the right angle. And so then we can just we'll call so this is the hypotenuse, so we'll call that the x, and we'll call this the y component. So the cosine, so what we're going to do is we're going to find this and this, that this would be the perpendicular vector, this would be the parallel vector. So the cosine of 34 degrees is equal to the adjacent, so the x over the hypotenuse, so it'd be x over 250, and so x is equal to 250 times cosine of 34 degrees. So 250 times the cosine of 34 degrees, and I get like 207.3, approximately 207.3 pounds, if I round to the nearest tenth a pound. And then for this component, this one would be the one that is parallel to the ramp. So I have sine of 34 degrees is the opposite, which is y, over the hypotenuse, which is 250. And so I get y is equal to 250 times the sine of 34 degrees, and this is equal to, so 250 times the sine of 34 degrees, and I get 139.8 pounds if I round to the nearest tenth of a pound. So this would be the amount of weight this guy would have to counteract in order to hold that 250 pound weight in place on the ramp. So okay, so that completes this section of vectors, and in a little bit we'll have a second set of videos for the next section.